Welcome. The title of today's notes worksheet is the unit circle. And as a matter of fact, the unit circle represents really the most important visual tool for understanding our 6 trig functions that we're going to be looking at all unit long. So we're going to kind of build that foundation today, and as a matter of fact, we're going to introduce the 6 trig functions for the first time today, all within the perspective of the unit circle. So we're going to start it out here. I have a little investigation at the top, and it says the equation x squared plus y squared equals 1. And as a matter of fact, if you don't mind boxing that up for me, that would be the equation for the unit circle. So if I put all the x's and y's in that equation that make the equation true, I should say, it would form a perfect circle on the coordinate plane. And really, a and b is the important piece to this. As we have potentially seen before, the center of the unit circle is going to be right at the origin there. So the center is going to be at 0, 0. And the radius of the unit circle, and here's really the most important piece, the radius is actually going to be 1 unit. And so what we're going to draw momentarily is exactly that, having a center with the circle with the center right at the origin and the radius of exactly 1 unit. And then we're going to talk about some connections from material that we've seen before and see why it's so important. Again, it's a great visual tool for seeing some of these trig functions form and all their values and so forth. So let's just work off to the side here for a sec. And if you get a chance, let's go ahead and just do a coordinate plane. And exactly that piece, everyone. I need a center at the origin and a radius of exactly 1 unit for our circle. And here's what I'm going to ask us to do. Obviously, we can put the center at the origin nicely there. But what I'm going to ask us to do is sort of illustrate this, that it's 1 unit by putting a little 1, 0 right there. So that would tell us that the radius of our circle is exactly 1 unit. So it says on your paper, kind of coming back to this piece, it says sketch the unit circle and label arc length and a central angle. So what we're going to talk about, of course, is a point moving in circular motion. We're going to talk about that point moving in circular motion, along the unit circle. So let's go ahead and sort of sketch that out right there. Go a certain distance, and of course that would be the arc length, the distance traveled around the unit circle. Now remember what we talked about when we looked at circular motion. There is a central angle tracking that point, well really I should say a terminal side tracking that point, and the angle changing as a result. So everybody here's your theta, of course, in place right there. Now in this case what I'm going to do is just put a little r for right now, because that's the formula that we've been talking about, that S equals R theta. And then I need us to start thinking about a couple things and draw a good conclusion with this. So I have my unit circle. I have my arc length around the unit circle. I have my central angle as the terminal side tracks it. And I have my radius. So we have that piece. We have part C taken care of there. That's great. And now everybody, let's look at part D. It says look at the formula S equals R theta on the unit circle. What conclusion can be drawn? So here's what I'm going to do. I'm just going to write our formula right here, S equals R theta, and then I want you to just think for a moment, why is the unit circle so special in relation to this particular formula? So think about it for just 1 sec, and then come on back and then let's look it over. So if you look at the diagram there, I have my S, I have my theta, and I put an R right in here. But as a matter of fact, I know exactly what R is equal to. R is 1. And so in this particular case, I end up getting with the radius of 1, you can kind of see that unfold, everyone, that if S equals 1 times theta, then the arc length itself is equal to that central angle in radians. And so from a visual perspective, we can really start to understand the connection between the angles and the distance around the circle. And that's going to help you so much with the visualization process of sine and cosine and tangent and all that stuff. So I hope everybody is okay with that piece. The arc length around the unit circle is equal to the central angle. And so let me be pretty specific about this on your paper. You draw it the same. But basically, here's what I would say. The arc length is equal to, and here's where we have to be a little careful, to the radian measurement of the central angle. I've been asking you lately to really visualize some of those angles in degrees and radians, and that's important for us to take this next step forward. So the arc length is equal to the radian measurement of the central angle, and now because they're the same, they're both actually going to be denoted with the same letter. So both are denoted with, and we'll see this as it can be any real number, so with the real number t. So you're going to hear me talk a lot about our t values over the next few days. And so in this case, what that t value is going to represent, as a matter of fact, it's going to have a dual meaning. It's going to be the central angle in radians, and it's also going to be the arc length around the unit circle. So t is going to represent two things simultaneously. Okay, so I hope everyone's okay with that. I've drawn my unit circle for the first time. And what makes the unit circle special is the fact that the radius is 1, and so the arc length of the circle is equal to the central angle in radians. If I can visualize this, then I can visualize how far around the circle we've gone. Okay, well, we're just going to keep building on this idea. So let me read what I have on your paper at this point. It says, as a point moves around the unit circle, it can move clockwise or counterclockwise. In addition, each point on the unit circle corresponds to an x-coordinate and a y-coordinate. Draw two coordinate planes in order to illustrate these concepts. So we'll do it twice over. Again, just the more we see it, I think the more we're going to get a feel for it. So everyone, if you get an opportunity, let's just go two coordinate planes, kind of side by side there if you get a chance. And let's go ahead and draw the unit circle on the first one, of course. So something like that would do. Center definitely at the origin, and radius of exactly 1 unit. So that's the easiest way to show that. And then what we're going to do now is start working around in both directions here, clockwise and counterclockwise. And so the first one I'm going to start off just moving around counterclockwise from our initial point, and I'm going to just go a certain distance and stop. And remember, of course, the terminal side is tracking that point moving around the circle. And what we have now found, everybody, is that these two values right here, these two quantities, the arc length and the central angle, are both denoted by the same number. In this case, we're going to call it our t value. So that's what t is going to be. Those would be the same things. And you can also see as we move around the circle, obviously, each point on the unit circle corresponds to an x value and a y value. So I'm going to just go ahead and put a point and then x comma y right here. And you could also see, if you're really thinking dynamically with this, is that you can also see as we move around the unit circle, the x-coordinates and y-coordinates are going to change. How they change is exactly what we're going to explore. Okay, perfect. Let's see, I have everything taken care of. Just one thing to note in this, and actually let me go ahead and put a little arrow there to show that we moved counterclockwise. And we've talked about this before, but a counterclockwise rotation in terms of an angle, and now also moving around the unit circle, counterclockwise rotation, t is going to be positive. So remember, we've talked about this before. Direction matters in trigonometry. So counterclockwise, everybody, t is going to be positive. Okay. Let's go ahead and draw a secondary one just over here. Same thing. And let's go ahead and show that this is going to be the unit circle over here as well. And let's go ahead and, in this case, move around clockwise here. Just your choice how far you want to move. I'm just going to go around a certain number of units, kind of stop right there. So this would be our t value, the number of units moving, in this case, clockwise. Terminal side tracks it to the point, and so t is also going to obviously be from here to here. Perfect. And as a matter of fact, I'm just kind of looking at this other drawing. If you want to fill that in, just kind of caught my eye. Again, always want to include the rotation on t, because there really theoretically are an infinite number of ways to get from the initial point to a terminal point on the unit circle. So we do want to indicate the rotation. Okay, so this looks good. And of course, you can see we have a point on the unit circle, so that point has an x-coordinate and it has a y-coordinate. Now, if you remember correctly, we talked about angles being negative when we rotate clockwise. In this case, same thing with the unit circle. So clockwise rotation, of course, t is going to be negative. And so you could already get a sense based on these two diagrams that really t can be any number. because I can go an infinite number of units around. I can just keep going infinitely counterclockwise, or I can go an infinite number of units around clockwise. And so you can see that t really can be any number as a result. Okay, good. Let's move on to the next piece. So here's what it says. The relationships among x, y, and t are defined by 6 trigonometric functions. Each trig function is defined by a name. Let's get rid of that right there. By a name as opposed to a letter. So if you remember all the other functions we've been looking at up to this point in time, for all the families of functions, it's always been f of x or g of x or h of x or whatever the case may be. A function always defined by a particular letter. The trig functions are a little more unique in the respect that we're going to be talking about the sine of x, the cosine of x, et cetera there. But we're not quite there yet. We're going to get a unit circle perspective on those trig functions first, but that'll be the idea, is that each one has a name as opposed to a letter. So there are 6, as it says. Some of these I think you've had an introduction to before, but not probably in this context. So let's start it out here. We're just going to go row by row. The first function, of course, is what's called the sine function. And the abbreviation for sine, everybody, is going to be SIN. So you'll see that on your calculator. And basically, because these are functions, they're going to have inputs and outputs. So that's what this next piece comes along, where it comes along. Now, the definition, of course, is only in relation to the unit circle, everybody. So those t values are going to represent my inputs. And what I'm going to do is actually take the sine values of those inputs. And when I do that, everybody, I get an output. And the output on the unit circle happens to be the y-coordinate. And so what you want to do is start making some mental associations with these trig functions. Whenever I hear the word sine, I immediately start thinking about y. Again, whenever I hear sine, I think about y. Even when we expand our definitions beyond the unit circle, and we definitely will, it still really works visually when you hear the word sine to think y. So the input, again, is going to be t. So our t value goes in, and the y-coordinate comes out. Whatever that y-coordinate is on the unit circle, that's our answer, our output. Okay, now the second, and by the way, these two right here are probably the most important two for our units. We're going to see most of our work with sine and cosine. So cosine is the second one. COS, everybody, in terms of the abbreviation. Now, same idea, of course. What I'm going to do is take the cosine value of our t, and when I take the cosine value of our t, something comes out. In this case, what comes out, everybody, is the x-coordinate. So when I hear sine, I think y. When I hear cosine, I think x. And as I said, even when we really talk about these functions beyond the unit circle, it still works out very nicely. Okay, and let's see. So t, and then the x. Third one coming your way, of course, is going to be the tangent function. Okay, write that in there for me if you would. And the abbreviation is going to be TAN. And so these are going to be our primary 3 trig functions, sine, cosine, and tangent. Again, most of our work, everybody, will be with sine and cosine, but also a lot of work with tangent as well. Okay, and so let's see, tangent of our t value. And in this case, when I take the tangent of our t, we end up looking at it as a ratio of y to x. And obviously, well, you'll see this kind of come through the entire unit here. A lot of trigonometry is really based on ratios, and so this is the first one where you see it explicitly. Even sine and cosine will be ratio oriented, but this one you can see right off the bat. Okay, t goes in, everybody. Y over x comes out. Okay, good. Let's get now our secondary 3. Now, everyone, the secondary 3 are going to very simply be the reciprocals of the primary 3. So the way I did this was sine and cosine and tangent as the primary 3. Now I'm going to lay out the secondaries as those 3 reciprocals. So the fourth one is what's called the cosecant function. And the abbreviation, everybody, is going to be CSC. And the cosecant function, very simply, is the reciprocal of the sine function. So when I take the cosecant of t, it's basically the reciprocal of sine. So it's going to be the 1 over y as opposed to y over 1. Okay, so in this particular case there, cosecant, whenever I hear that word, immediately I associate it with sine. They are reciprocals of one another. Okay, so t goes in, and 1 over y comes out. Okay, 4 down, 2 to take care of here, everyone. Number 5 is what's called the secant function. So secant, we're going to associate with cosine momentarily. And again, not easy to kind of put together, but you're going to have to make these associations. Cosecant is the reciprocal of sine. Secant, everybody, is the reciprocal of cosine. So secant of t is going to be 1 over x. Okay, great. And let's see, I have my t value going in. And of course, everyone, that would be 1 over x as the output. Okay, I guess we can get our last relationship here. Cotangent and tangent actually have 2 relationships that we're going to explore, but one of which we'll see right here. So cotangent is the last one. COT, everybody, is going to be the abbreviation that we're going to see. And of course, cotangent of t, so our t value represents our input for all 6 trig functions, again, on the unit circle. And in this case, if it's the reciprocal of tangent, instead of y over x, everyone, it's x over y. T goes in, and then x over y comes out. Now we're going to talk a lot about these values as we go through the process. But for right now, just in terms of looking at this table right here, you're going to have to know pretty well. So again, associate things, that's the key initially. When you hear sine, think y. When you hear cosine, think x. And then kind of work your way from there. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, etc., etc. Kind of work your way through some of those. Okay, well, we're going to put these into action on the back side there. I believe I have 4 examples. And the way I was thinking about this is that I would definitely do 1 with you all the way through. I would probably ask you to pause the video and you try 2. Then, obviously, I'll give you the answers for 2. Then we're going to repeat. I'm going to do 3, and then I'd ask you to pause the video and you try to do 4. Because 1 and 2 are basically identical. 3 and 4 are basically identical. And just especially 1 and 2 at this point are the ones I need you to be able to take care of. And then you'll see there's no notes worksheet coming on the next lesson. You're going to actually construct the unit circle, and we're really going to start looking at some of the values as t changes. So that's the important piece, but this is a good foundational aspect for us, so we'll start that. Okay, let's go for it. So example 1, there's a point, -1/2, comma √3 over 2, is a point on the unit circle that corresponds to a t. Now basically that point theoretically can correspond to an infinite number of t's, but for right now it just corresponds to a t. Find the values of the 6 trig functions at t. Great. Now you don't have to be visual with this, although I think I'm going to start you out that way. So everyone, if you get an opportunity, just off to the side here, let's just go ahead and draw ourselves a unit circle. Just really get ourselves kind of thinking about this. So here's the 1, 0 right here. Now as it says, this is actually a point on the unit circle. We are going to actually see this point on our construction tomorrow. But for right now, everyone, what I'm going to do is show you where it is. It should be about right there. -1/2 and square root of 3 over 2. So let's put that in. -1/2 √3 over 2. See if you can get that on your paper. And remember, of course, with that point moving around the unit circle, there's a terminal side that goes with it. Let's get that in there. And here's the idea very simply. Again, theoretically, going from the initial point to what I would call a terminal point, there are an infinite number of ways to get there. I could go just from here to here. I could go clockwise. I could go around more than once. There, again, it's theoretically an infinite number of ways. What I'm going to do is just go with what I would call the primary rotation around, just counterclockwise from there to there. And we'll just call that our t just for the time being. Okay, it doesn't specify t, and in this case, we don't have to know t. But basically, we would go that many number of units around the unit circle. This would be the central angle in radians, that is the same, and we would land at that point, negative 1/2 root 3 over 2. Okay. Now again, this just goes back to that front side, everyone. Start making those connections if you would. I'll try to box up each one here with a final answer, just so we're pretty clear on what I'm expecting, but we'll just kind of do the work all through the space here. So everyone, you're going to start it out. Let's go sine of t, and don't overthink this part. Basically, when you hear the word sine, think about that y coordinate. So for this particular t value, very simply, the y coordinate is square root of 3 over 2. And that is a number that comes up quite a bit in trigonometry, so this is your first introduction to it, but we'll see it a lot. So sine of t is equal to root 3 over 2. And I don't know, I guess I will box it up. So there you go. That's the first answer. Sine of t is root 3 over 2. Now again, t is your input. And remember, everybody, these are functions, so please write it completely like this as a mathematical sentence. Sine of the input, in this case we don't know the input, so it's just t, equals the output, square root of 3 over 2. Try not to shortchange this mathematical sentence. Okay, next one here. Let's do cosine. So cosine of our t value, very simply, whenever I hear the word cosine, I think x. And so in this case, the cosine value for this t is negative 1/2. And that's good. Okay, so we've got 2 down, and now we have the other 4 to take care of. So tangent of t, now it's going to get a little dicey here, but let's see what we can do with it. So tangent is y over x. So square root of 3 over 2 over negative 1/2. Now there's so many different ways to kind of look at this, so you're going to have to go with what's comfortable for you. But basically, we don't kind of deal with fractions or within fractions, so we're going to try to clean this up quite a bit. Couple things that I see. Obviously, the one thing that jumps out at me is both of the denominators are 2. So theoretically, if they're both divided by 2 here, really those do cancel out. The 2's cancel, and I just get the root 3 over negative 1, which we'll write momentarily. If you don't see that, everybody, I think I've shown some tricks to this before, but basically there's what's called the outside over inside trick. So you could do this times this over this times this. I'm going to just do it that way for the time being so you can just kind of see it. But if I did the outside over the inside, I get 2 root 3 over negative 2. And you can see these are going to cancel here. And really, trying to make a long story short, you end up getting negative root 3 as a result. So the tangent of t, and see if you can play that out mathematically. If you have a different approach to that, please utilize it. It's not that big of a deal, but would be negative root 3. So tangent of t we have, and that's looking good. So again, every t value really has 6 trig functions that go with it. These are, well, 3 of the 6 for this particular t value that I've drawn. So root 3 over 2, negative 1/2, negative root 3 so far. Okay, good. Now let's get the secondaries taken care of. Cosecant is next. Cosecant very simply is the reciprocal of sine. So here's how I do it. Rather than doing 1 over y, which is how I defined it before, so instead of doing 1 over this root 3 over 2, in my opinion, it's just a little easier to flip the sine value. So if the sine value is root 3 over 2, then I would say the cosecant value is 2 over root 3. So again, everyone, you can do this so many different ways. I want to go with what works for you. But instead of doing 1 over y, it's just simpler to flip the y value, and you get this. Now, this comes up quite a bit, and me, like all the other trig teachers, are going to have to be somewhat sticklers about it, rationalizing denominators. So you've seen this before, certainly in your algebra classes there. So let's rationalize this. How do I get rid of a root 3 in the denominator? The easiest thing to do is multiply by root 3 over root 3. Okay, you've definitely seen this before. 2 times root 3 on top is 2 root 3. Root 3 times root 3 is root 9, or really just 3. So cosecant of t, everybody, is 2 root 3 over t. I'm sorry, 2 root 3 over 3. Cool. And 4 down, 2 more. Try to take care of secant of t. Again, secant is the reciprocal of sine. Rather than doing a 1 over the negative 1/2, what I do is just flip the x value. So instead of negative 1 over 2, it's just negative 2 over 1. And again, it's up to you how you want to do this. That is definitely correct. But the secant value for this t is negative 2. Excellent. And then we have one more to take care of here. It looks like cotangent. So cotangent of t. And guys, cotangent of t is really x over y, or the reciprocal of tangent. So I just treat it as this one. So everyone, this is your tangent value right here, negative root 3. And I can almost think about it as negative root 3 over 1. And so if it's negative root 3 over 1, everyone, then this would be its reciprocal, 1 over negative root 3. And again, all that means is it's just going to be a negative value here. I'm going to rationalize this momentarily. So let's go ahead and see what happens. Same deal, everybody. Let's go ahead and multiply by root 3 over root 3. And when all's said and done, hope everybody is in agreement that 1 times root 3 is root 3. Root 3 times root 3 is just 3. So the cotangent of t is negative root 3 over 3. And there are your 6. Goodness. So that's what we're looking at, being able to kind of pull that off. If I give you a point corresponding to a particular t value, you can give me all 6 trig values at that t. Okay, good. Again, what I'd ask you to do is maybe pause the video and try it for example 2. I'm going to go a little faster on example 2. I guess actually before you pause it though, as I'm just kind of thinking out loud with this, let me just show you where it is. These happen to be other numbers that we're going to see quite a bit of, these root 2 over 2s. So you're going to see a lot of 1/2s, root 3 over 2s, root 2 over 2s. Well, everyone, this one happens to be down in the 3rd quadrant, and as a matter of fact, it's going to be right there. That's that point. So let's go ahead and put that in place. So negative root 2 over 2, comma, negative root 2 over 2. Okay. And again, here's your terminal side. There are, as I've mentioned before, an infinite number of t's that can get us from this point right here, this 1 comma 0, to this point all the way over here. But this is just the most common t. And so remember, t has a dual meaning, everyone. That's key. It represents 2 things: how far we move around the unit circle and the central angle in radians. So we don't need to know t to work with this particular problem. T is just going to be your input. But basically, can you come up with the 6 trig functions at t? Okay, so pause the video. Try it for a sec. See if you can pull it off. And then we'll come on back and do it. Okay, let's see how you did. So when I looked at this, sine of t is just the y value, negative root 2 over 2. Cosine of t is just the x value, again, negative root 2 over 2. Okay, so hopefully you were able to do those nicely. I'm going to come right over here and do tangent of t, and again, look at it as clearly as I can. So it's y over x, so negative root 2 over 2 over the negative root 2 over 2. And obviously, guys, you would simplify this, and I'm hoping everybody recognizes that when you divide anything by itself, you end up getting 1. And so as a matter of fact, tangent of t is equal to 1. Then, everyone, we would go ahead and try the secondaries, really the reciprocals of those primaries right there. So again, instead of doing 1 over y, I just flip. So in this case, it would be negative 2 over root 2. Again, please rationalize. So in this case, what I'd be looking for is to multiply the top and bottom by root 2. And let's see what happens. In this case, you get negative 2 root 2 over, and then it looks like 2 on the bottom there. And then just good algebra, everybody. A lot of good algebra ingrained in the trigonometry course. The 2's cancel, and that's what you end up getting right there. So cosecant of t is negative root 2. Okay, good. Let's see. It looks like same deal with secant of t. Hope you don't mind me shortchanging it here, but you would do the exact same thing. So you'd flip that cosine value. And when you rationalize, believe you do get negative root 2. And then last one, everyone, would be flipping the tangent value. And remember, the tangent value is 1. Flipping 1, everybody. Remember, don't forget one thing, just maybe it's come up over the years, is the signs stay. When you flip something, you don't change the sign. So notice if sine is negative, cosecant is negative. If cosine is negative, then secant is negative. And if tangent is positive, then cotangent is positive. So when you flip, don't change the signs. All right, and there are your 6 for that t. Looking good. All righty, everyone. Last couple. Again, I'm going to walk you through 3. You're going to try 4. And we'll actually try on the calculator too here momentarily to confirm a couple things. So now, everybody, I'm going to give you a particular t value. And so it says find the values of the 6 trig functions at t equals pi over 2. So what I'm going to ask for, everybody, is the sine of pi over 2, cosine of pi over 2, etc., etc. Okay, well, let's give it a try here. So I guess the first order of business, everyone, is to draw my unit circle. And you'll hear me say this a lot, see it. We've got to really visualize it. So here is the key. Here's the key to success with all our unit circle stuff, especially when we do our construction and then we do our practice on it. In order to know some of these values, we have to picture ourselves on the unit circle. Where are we on the unit circle? You'll hear me ask that a lot. So the question, of course, is if t is pi over 2, where am I on the unit circle? Now think about what t means. Remember, t is 2 things. It's how far I move around the unit circle, but it's also the central angle in radians. And so you can see I've really been emphasizing the connection between degrees and radians because that's going to be your association here. My hope is that if you understand that t is pi over 2, that you can actually visualize the angle of pi over 2 radians. Now remember, everybody, pi over 2 radians is 90 degrees. And so now you can hopefully start to get a sense of, okay, here would be an initial side with the initial point, and if t over 2 is, if t is pi over 2, then basically what that means is that's pi over 2 radians right there, from there to there. That's pi over 2, and that's your t value. Which means, of course, moving around the unit circle, I've gone exactly pi over 2 units if I've gone from there to there. So that is where I am, everyone. That's t as pi over 2. I hope that makes sense. 90 degrees, I know you can all visualize 90 degrees, and as a result, you can visualize pi over 2 radians, and then as a result, you can visualize working around the unit circle. Okay, so here's the only thing we need. The question, of course, becomes, what's the point? So remember, of course, as the point moves around the unit circle, x's and y's change. Here, guys, I'm at the top of the circle. It looks to me like the x-coordinate is 0 and the y-coordinate is 1. I hope everyone's okay with that. Right there, everyone. X is 0 and y is 1. If I know that, do I know all the values of the trig functions at pi over 2? Sure. And so let's do them. And we're going to confirm these on the calculator. So everyone, sine of pi over 2 is just the y-coordinate. So as an input, pi over 2 is the input, 1 is the output. Okay, cosine of pi over 2. Pi over 2 is the input, 0 is the output. The cosine value at pi over 2 is 0. Tangent of pi over 2 is y over x. Well, think about this one. This is going to come up a lot for us as well. Can I do 1 divided by 0? No, absolutely not. So the tangent, oops, I missed something there. Let me just erase so I can get it right for you. I put it as a t. Didn't mean to. So tangent of pi over 2 is, of course, undefined. So not all the trig functions are defined at every single spot. So tangent of pi over 2 is undefined. If you want, you can start boxing them up, kind of final answers there. There are your primary 3, of course. Let's go ahead and get the secondary 3. Cosecant of pi over 2, flipping 1, everybody. That's the easiest way to do it, and really flipping 1 is just the same as 1. So cosecant of pi over 2, everybody, is 1. Now this one's an interesting one. Secant of pi over 2 is flipping 0, or really 1 over x, or 1 over 0. Again, I get the same situation where I can't flip it with the 0 in the denominator, so secant of pi over 2 actually is undefined. Okay, great. And then the last one, of course, is cotangent. If it's tough to kind of talk about it, ooh, flip undefined, if that doesn't make any sense to you, then remember, just fall back on it's x over y. Cotangent is x over y. In this case, it would be 0 over 1. And so the cotangent of pi over 2, everyone, is going to be 0. 0 on top is 0. 0 on the bottom, of course, undefined. Now, guys, everyone pick up the calculator. Watch this. So everyone, if you get a chance, hit mode, and please make sure you are in radian mode on your calculator. So this is the branch of trigonometry called the trigonometry of real numbers. And then come on out of there, and what you're going to do is type in sine pi, there it is, divided by 2, and look what you get. Sine of pi over 2 is 1. Now your calculator is not thinking, oh, this student is working on the unit circle. I need to give that y value from the unit circle, which is 1. Absolutely not. When we define our trig functions beyond the unit circle, this value will hold. The sine of pi over 2 is always 1. The beautiful thing about the unit circle, what makes it so great if I come back over here, is I can envision it. If I can see myself up here at the top of the unit circle, I can picture the y-coordinate as 1. And so the sine of pi over 2 is 1. Excellent. Let's do cosine pi over 2. Same deal, just confirming it, and take a look. Cosine of pi over 2 is 0. Same deal. When we expand our definitions, this will still hold, but you can see it on the unit circle. That's what makes it so great. And then last one here, tangent pi over 2. And as you can see, we have a domain issue, undefined. So tangent of pi over 2 is undefined. So again, it's good to kind of confirm some of that. Alrighty. Before we wrap this on up here, everyone, I'd love for you to do example 4. So think about where are you on the unit circle if t is equal to pi. So take a moment, and if you would, pause the video and see if you can go 6 for 6. Okay, let's see how you did. So here is my unit circle. Here's the 1, 0 starting it out. Now we're getting into a rhythm with that. If I've gone pi units around the unit circle, I've gone right there, everyone. That is where pi is. T is equal to pi. That's where we know it is. So t is pi. Okay, excellent. Now the only order of business really to be successful after we know where we are is to think about that point. And that point on the unit circle, everybody, is -1, 0. That's the point at t being pi. And so as a result, now it flies. Sine of pi, everybody. Again, I hope you've done these. Sine of pi is 0. Cosine of pi always is, always will be. Cosine of pi is -1. Tangent of pi, this would be y over x. And so this would be 0 over -1, which is just 0. And then if I kind of do my flips, cosecant of pi, trying to flip 0 is undefined. Secant of pi, again, notice the association here, everybody. Just it'll become more and more automatic the more you do it. Secant goes with cosine. Flipping -1 still stays -1. And in cotangent of pi, trying to flip 0 really just makes it undefined, getting 0 in the denominator. And there are your 6. So the next step for us is to actually do a beautiful big construction of the unit circle and seeing kind of our special t values and all the function values for those t's. We're going to really do that, and as said, that's probably going to be your primary study guide for the entire unit. There's so much that goes into really learning and understanding the behavior of the trig functions with the unit circle. So you will need a piece of construction paper for the next lesson. Again, it's not a notes worksheet. You're going to do it on a piece of construction paper. So just get that from me. And you'll need a lengthy ruler compass, and a protractor. Those 4 things. And as I said, you're going to make it look really good. You're going to use it all unit long. Okay. Well, guys, we'll take a look at that on the next one there. If you have any questions with this, let me know. There's really not too much work to do with this at this point in time, but you do need to know those 6 trig functions. So make sure you look at that table from the bottom of the front side. Thanks for listening, of course.